Okay, so right now I am unable to see the record option.
Mohit, I have started the recording.
The recording started.
Okay, okay. Thank you, sir. So so before I will discuss all the questions or uh, so please come up with your own doubts, as the purpose of this tutorial is to not just giving you the answers just of the question of the tutorial sheets. It is like you are having some genuine doubts, and then we will proceed further.
So I was unable to understand the question number 6 and 17. That's it.
Okay, question 6 and 17. Okay, and we will come to the question 6, and before question 6, are there any doubts?
I have doubt
No, sir.
how to do the questions. Actually, I know all the questions, but actually written part is weak to how to prove them. Representation.
So here, okay. So here the questions are like not so like if you can see this question number 1. So here we have I'll just discuss how to write or how to answer the questions like this. So here you don't have not very much to prove, but here you have to interpret like it geometrically. So if you can see the system of linear equations given, and you can here geometrically, if you can present this system, then you can interpret the solution. So here only you can write by drawing the equations on your graph or anywhere, then you can interpret the answer. So in this question, like you can see here for like these two lines are parallel. If you put some values over this these constants like a1 b1 a2 b2 and a3 b3, and likewise c1 c2 c3, then based upon this you can get this line L1 L2 L3. Okay, so here the solution is the common point of all the lines, like where this L1 L2 L3 intersect at a common point. We say that that will be the solution of the system of these equations. So here you can see that okay, there is no point of intersection of the three lines, then we can say that there is no solution. There can be another possibility where the two lines are coincide, but other line is parallel, not coinciding with the two lines, and it is parallel with the given two lines. So this is the possibility, and again is the case of the no solutions. So here so based upon the question nature, you can answer the question. So right now it is like geometrical interpretation, then you are able to give an answer by just drawing uh, drawing the linear equations, and there are the several cases. So here there is another possibility where the two lines are parallel, but other line is not parallel to the given two lines. So but again so can anyone tell me in this case is the solution possible?
No, sir.
Hmm.
No, sir.
No, sir.
Yeah, yeah.
No solution.
So no solution. Likewise, in the second case here also the solution is not possible, although the lines are no two
Yes, sir.
lines are parallel to each other. So in this way, you can answer this question like form the cases, many cases, as many possible cases for the three lines. So the unique solution case like you can draw is the following: this L1, L2, L3, where one point is a common point, and you can say that okay, this is the point of intersection, the point of the common point of intersection, and that will be the solution of the system. And okay, this is the another trivial case you can see. So so the question one is for two dimension, and this the question two is again in three dimension, although the nature of the question remains same. and one can notice that that the three lines, actually these are not lines, these are planes.
Flames.
Yeah, so these are planes.
Hello,
So
sir.
yes.
Hello, sir.
Mhm.
So in question 1, what condition of A1, A2, A3 in infinite many solution case in question 1? Because the question says the further provide values to AI, BI, CI.
So yeah, so you tell me. So so okay, the
Sir,
solution is the. Yes, yes. You
the
just
two
complete
case
your
is
question.
fine. No solution case and unique solution case I find, but in infinite many solution I have doubt. So I am asking.
Okay, okay. So what is the solution? Okay, so in question 1, there are three lines. Okay, and
Yes, sir.
what do you mean by a solution? What do you mean by a solution of the given system of linear equation? So that is the question, right? This question 1, the three. So these are three lines. That point is clear, right? Because it is a1
Yes,
x
sir.
plus. Okay, these are the equation of straight line. Now, for these three straight lines, what do you mean by a solution for this system of? You can also say this is a system of linear equations. So, what do you mean by a solution? So, one guy is asking now. I'm asking to him.
A pair which satisfies all three
So,
equations. A pair which satisfies all three
so
equations.
geometrically, if you interpret, so if you interpret this geometrically, this means that if you draw these three lines, then the point where the infinitely many solutions, so all those points which will satisfy these three equations simultaneously. Okay, so if you say the number of those points are infinite, the points are infinitely many, then what is the case where this can happen? Forget about all these equations, just geometrically if you think
Actually,
of.
sir,
Sir, if
I
they are
guess
coinciding,
A2 equal to lambda 1 A1 and A3 equal to
Say
lambda
one by
3.
one. Mhm.
sir, if they all are
A2
coinciding,
and A1 are linear combination of each other. I guess this coefficient.
So when all the
Yeah,
three lines
Yeah,
overlap,
all the three lines must coincide.
yes, that is the case that I want to. That I want to come up with that person, but okay. So that is the case. Yeah, exactly. This is the case, right? But as you say, the linear combination, just go. So we will see mathematically what do we mean by these terms, linear combination and all these things. But right now, these are just straight lines. These are just like your class 11th or 12th these questions. So these are the straight lines, and the possible solutions are like common point of intersection. Okay, so that you can say that is a solution. So the point where this can happen, you can see that in part C, the system has infinitely many solutions. This can happen only if and only if this L1, L2, L3, all these equations L1, L2, L3 are same. Okay, so you can say here, you can say for this A2 equal to A1, B2 equal to B1, C2 equal to C1, also A3 equal to A1, B3 equal to B1. I mean, these all the A1, A2, A3 are same, and this B1, B2, B3 are same, and C1, C2, C3 are same. And then then it is possible the infinitely many case. Is the doubt clear?
सर नो सॉल्यूशन होने के लिए पैरेलल का ही होना जरूरी है.
नहीं सो नहीं ऐसा नहीं है ना, हमने देखो एक केसेस देखे यहाँ पे. So here you can see, इधर आपने देखा कि the three lines, no two lines are parallel, but there is no solution. So that is also the case.
Yes, sir.
So in this case, we have to also find out AI, VI, and CI. So in this case, how to find out AI, VI, and CI? Do we have to
So
find out all intersection and then implying condition that these three intersections should be different?
can you repeat your question? The last line, whatever
So
you
in
said,
this,
that I understand.
so in this question, we have to also find out AI, VI, and CI. So in this case, how to find AI, VI, and CI?
So how to find. So like based upon this, so these are the examples, not the just the complete value. So these are the example to illustrate how can you put the values of a1 a2 and a1 a2 a1 b1 and c1. Okay, so for this case, like I am telling, for the case where the system has infinitely many solutions, so you can answer that this can only possible where a1 a2 a3 are same, b1 b2 b3 are same, c1 c2 c3 are same, and a1 b1 c1 can take any value, so that you can answer in this way. And
No, sir.
for the
I am asking for case 1, sir. System has no solution. And for the third case, triangular form.
third case, I mean, okay, for this one,
It's a triangular form. Yes, this one.
okay, you are saying it as a triangular form. So that is also not pretty much difficult. So you can also answer by yourself, because you can see that the both, I mean, all the three lines are not parallel to each other. So you can
So do we have to calculate all three intersection point and imposing the condition that these
no,
three intersection points should be distinct?
no. So so, so you are saying, okay, you are I mean, generalizing. That you can also do, but that will take you, I mean, that will make your life more difficult. First of all, please mute yourself after asking the question. So for the first point is that here you have to interpret this geometrically. So here for all those who are worrying about how to represent the general, this a1 b1 a2 e2 and these points, this is not the case. Okay, so here it is asked that also provide the values so that we can say of the statement holds. So you can say, like for this L1 L2, you can just, so you can see that this L1 L2 are not parallel to each other. So you can take the line, so what is the slope of this line L1? If you can recall the slope of this line L1, so if I ask you what is the slope of this line L1, giving this, the equation is
minus
A1.
Minus a1 upon b1.
a1 by
Minus
b1.
a1 upon b1.
So you can take this line L2 in such a way, this minus a1 upon b1 is not equal to minus a2 upon b2. So okay, so all those possible values, this can I mean, this can take, and again you can you can also take care of this L1 L3 and L2 L3. Okay, so all the possible values
Okay, sir.
Yes, sir.
satisfy, which will satisfy the slope where the slope are not equals. Okay, and also
Instead
you
of
yes,
sir, instead of listing all the examples of all the cases of what can we instead say that the lines will not be concurrent and then give an example of that?
line be not concurrent and given example of that. Yes, you can say, but the question, like the nature of the question, that one person is saying, okay, I want the values, the particular values of ai bi, I mean ai bi and ci, so that this is the case for the third case. So that's, of course you can say that also, that is the correct one, but he's asking some particular thing, that okay, what is the particular values of this for this case, and the a1 a2 I mean ai bi ci. That's what I was just explaining.
Thank you, sir.
I hope it works, and you just try with yourself, and if further, if there is any discrepancy, then we can discuss it later also. Is it making sense, or
Yes, sir.
Okay, sir.
Yes, sir.
Yes, sir.
Yes,
No
sir.
problem.
Yes, sir.
okay?
We can ask
So so for okay, so like for the question 2 also, this the nature of the question remains same, but here we have the plane, so we have to little more careful about these the cases. But yeah, so you can say that for the all the planes are parallel. So again, here the for the case, for the interpreting it geometrically, because we have to give some particular values for this a1, b1, c1 and d1, I mean this for the three equations. So we have taken some particular examples. Okay, so to interpret this geometrically, as you can see, this p1, p2, p3, these are the condition where all the planes are parallel, but this constant is different, so we can see this form in this figure. So again, this has a no solution because there is no point of intersection. There is no point common between these planes. Okay, and also further, if the two planes are coinciding each other, and the third plane is just parallel to the above two planes, then again there is no solution. And here also you can see there is again no solution case. And also the case which we were discussing right now, I mean in the previous question, that is also here in the 3 dimension. So the unique solution can only possible. So here, as you can see here, the planes which are special here, this plane x equal to 0, y equal to 0, and z equal to 0. So the point which is common here is the origin, that is 0,
0, 0, 0.
Yes, and that is the only solution for the system of linear equations given. And so okay, so can anyone tell how this the infinitely many solutions case is possible? Because in line, in the 2 dimension case, this can only possible where all the 3 lines are coinciding each other. But in planes, will it be the case the same, or we can have still some different case, but also with infinitely many solutions?
अगर सभी
if they
सभी प्लेन
coincide
एक ही
on
लाइन
a
पे कोइंसाइड हो
line.
रहे होंगे, एक ही लाइन पे कोइंसाइड हो रहे होंगे.
Yes, very good. So is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So you can see here in 3 dimension case, there is another possible case where so here if anyone is generalizing the previous case, he see, okay, this can only possible where all the 3 planes are coinciding each other. That means the equation of all the 3 planes are same. But here you have some different case where the number of solutions are infinite, but the case is different. So as you can see, as one among you has pointed out that, okay, if we have the straight line which is common, then also we can have infinitely many solutions. So this is the case. So and where all the I mean all the equation of this p1, p2, p3 are same, then they are coincide, and again we have infinitely many solutions. Okay, so you just exercise again. I mean, those who have done very good. Those who have just tried, I mean, very. So you just rigorously try it. Try to write the questions. I mean, try to present it very well, so that it makes you more perfect in writing. Okay, so let us quickly see this the question 3. So any idea regarding this question 3? So in question 3 we have, this is the question, the statement, right? So can anyone tell me what is the approach by yourself, or any
Yes.
doubt? Yes.
Sir, there is a number of equation is 2 and the variable is 3. So the free variables also 1, मतलब एक वेरिएबल हमेशा फ्री रहेगा, तो यूनिक सॉल्यूशन का तो कोई चांस ही नहीं है. Then if we take 2 parallel lines, then मतलब x plus y plus z equals to 1 and x plus y plus z equals to 2, then there is no solution.
Correct.
And if we take 2 planes coincide, मतलब एक ही प्लान ले लेते हैं, so there is infinitely many solution, और यही एक कंडीशन केस होगा जहाँ पे infinitely many solution होंगे.
सर एक और केस हो सकता है, अगर दोनों कोइंसाइड करे तब, या फिर कोई एक लाइन पे वो लोग इंटरसेक्ट करे, दोनों केस में इनफिनिटली मेनी सॉल्यूशन.
Exactly. Though earlier you have said that is also correctly, but there is another case possible that the last the girl is pointing out, that is also correct. Very good. So that is also the case.
Yes.
So is there
Yeah.
any other case also possible for infinitely many solutions?
Yes, sir. Second plane is absent.
Absent means these are coinciding, right? This is what you are trying to say.
Same plane.
Same
Yeah,
plane.
yeah,
Yeah. So these two cases fine. I mean, you told me that the coinciding case and that another person that is telling me the case where they are intersecting at a line. I'm asking, is there any other case possible for the infinitely many solutions?
No, sir.
Okay, no.
I also
Yeah,
think no.
correct. Hmm? No issue. Very good. You have tried it well, and it is encouraging that okay, you just come up with your original answer, and we just discuss what is your thought process, and we just here try to, I mean, try to just see is it correct or not, or where is the error. Okay, so feel free to ask anything and just try to answer by yourself. So everybody is clear with this question. So the
Yes, sir.
geometrical interpretation.
Yes, sir.
Yeah. So yeah. Now, can you provide me the values of this AI, BI, CI, DI so that for the A part?
अगर इसमें लेंगे A1/A2 इक्वल्स टू B1/B2 इक्वल टू C1/C2 इक्वल नॉट इक्वल टू D1/D2 तो नो सॉल्यूशन होगा.
Okay. So no solution. So is there any other case, or is it only the case?
No, there can
Sir,
be other
only
cases
case.
intersecting.
So please, can you
There can be
so after
possible
asking question,
case.
can you please mute yourself because there is a disturbance come between the discussion. Yeah. Thank you.
There
Please
can
say.
be case possible.
Mhm.
If
Yeah.
both the planes are not intersecting, then they have no solution.
If both the planes are not intersecting, then they have no solutions. Yeah. So
So,
so yes, it is correct. And for the other case where the system has infinitely many solutions, although we have discussed it geometrically, but can you just quickly explain the what are the values of AI, BI, CI, and DI so that we can
A1/A2 equal to B1/B2 equal to C1/C2 equal to D1/D2.
Yeah. So okay.
Sir,
Yes.
sir, if D1 equal to 0 and D2 equal to 0,
homogeneous.
then
Yes,
sir,
then they, I mean, if D1 equal to 0 and D2 equal to 0, so these are the planes. Uh, I mean, so you can also interpret these are the planes passing through origin, right? I mean, because it will satisfy 0, 0, 0. Okay, if you take x equal to 0, y equal to 0, and z equal to 0, this will satisfy the equation of plane.
then sir, we cannot say na A1/A2 equal to B1/B2 equal to C1/C2 equal to D1/D2 because D2 is 0.
Because D2 is 0. Yes, so
So
you have
we
to
have to exclude that case.
तो दो केस बन रहे ना, एक के लिए ये, दूसरे के लिए वो वाला.
ही नहीं ना, वैसे भी वो इक्वली नहीं होगा.
So yeah, yes, you were what
नो
what,
सॉल्यूशन
what
ये इक्वली नहीं होगा.
yeah, what is the last argument that you have given? Hello.
Yes, sir.
The point clear? So where this d1 upon d, if you take, okay, so you are saying if you taking this d1 and d2 0, then this condition won't work. Then you just have to put the restriction, okay, when d2 is not equal to 0, because ultimately if this d1 upon d2 is the ratio is not defined. Okay. Or is there any other case possible for this case? Because we have discussed the two cases where the planes are intersecting at a straight line. I mean, at one common line.
जितने भी होमोजेनियस लीनियर इक्वेशन होती है उनके पास हमेशा सॉल्यूशन होता है. तो यहाँ पे वेरिएबल ज्यादा है और इक्वेशन कम है, तो ये इनफाइनाइट मैनी सॉल्यूशन रखेगा अगर होमोजेनियस लीनियर इक्वेशन है.
No. I'm asking not this one. I'm not asking the how many solutions it may have or not. I'm just asking. So we have, for the infinitely many solutions case, we have two cases geometrically we have discussed. One is all these two planes are coinciding each other. I mean the equation of these two planes are same. This is one case. Another case is that these two planes intersecting at a line, at a common line. So there is also the possible where the infinitely many solutions is possible. Okay.
यस सर z इक्वल्स टू 0 और y इक्वल्स टू 0 दोनों एक लाइन पे कोइंसाइड करेगा.
Yeah, so you just think it off. There may be some different possible cases. Okay, you can take like,
sir, if we take d1 d2 0, then we will always get infinite solution for any a1 b1 c1.
sorry, say it again.
सर हमने यहाँ पर d1 d2 0 ले लिया तो मतलब a1 b1 c1 के किसी भी वैल्यू के लिए मतलब इनफाइनाइट सॉल्यूशन मिलेगा.
यस सर ऐसा ही
किसी भी
होगा.
वैल्यू के
हाँ,
लिए
सर.
इन्फिनिटी मैनी सॉल्यूशन मिलेगा.
हाँ, क्योंकि सर होमोजेनियस इक्वेशन है, मतलब होमोजेनियस सिस्टम है तो 0 तो यूनिक सॉल्यूशन होगा सर.
Correct,
मतलब
exactly. Now,
हाँ,
yes,
एक वेरिएबल फ्री हो जाएगा.
Actually, I am coming to that point also.
एक
Yeah,
वेरिएबल.
yes. Complete yourself. Yeah.
हाँ सर वही बता. वही सर मतलब
Yes,
यहाँ
say
तो
it,
यूनिक
complete.
सॉल्यूशन नहीं होगा क्योंकि वेरिएबल ज्यादा है सर इक्वेशन.
Yes.
तो इनफिनिटी होगा
Definitely होगा. Yeah.
सर एनी वैल्यू ऑफ a1 b1 से.
Yes. That we have I mean discussed. Yes, and you have also pointed out that is also good, because just like this unique solution is not possible. Okay, as you already answered. So just these are the cases which we have discussed in this question, and the unique solution is not possible. So for question 4, what is your try?
सर इसमें c इक्वल टू a भी आया है आंसर में.
हाँ सर.
So is it okay?
c equal to ab.
क्वेश्चन नंबर 4 में c इक्वल टू a भी.
C equal to AB, yes. So how you have done that? That is fine. Answer is fine.
By example,
हमारे पास 3 इक्वेशन है, 3
the
इक्वेशन
values.
को सॉल्व किया है.
अगर w is equal to 0 हो गया, 0 वेक्टर, then c is not equal to ab. कोई भी चॉइस हो सकती है.
Say it again.
वेक्टर स्पेस है ना, तो ये सबके पास इनवर्स होगा भाई.
सर अगर w वेक्टर जो है वो 0 वेक्टर हुआ तो c और ab के पास कोई भी चॉइस हो सकती है.
Then but you have to, I mean, so this is for every vector. Okay, so because this x, y, w are in R square, so you have to tell me the relation between ABC where it is satisfying for every vector x, y, z in R square. Okay, there, yes, you are right, there are other possible choices, but you have to pick out all those choices which will satisfy for every vector. So here the condition is more restrictive, bro. So how you have done that?
Sir, I pre-multiplied the second equation by matrix A.
Second equation means this x equal to bw.
Yes, sir. Then we get the value of ax is equal to abw, and ax equals to y, and the value of y is given equals to cw. Then by comparing the corresponding matrices, we get ab equals to c.
Yes. So yeah. So here you can see the outline, that in that way you can answer, because it is a like for x1 x2, although you whatever you have said, that is also the correct way, but you just see, you can also answer in this way. Okay, is the thing is clear?
Yes, sir.
Yes, sir.
I have done this way.
Yeah, good, good. So the point is that you just keep trying the solution before I mean discussing the answer, so that you actually see the difference between you and the solution presented here or among with your friends. That is the purpose of these tutorials. Okay. So here this is the yes, say.
Mohit, just one thing I want to point out here.
Yes, yes, sir.
Yeah, can I?
Yes, sir.
So this is like, if you look at this equation, the last equation, CW equal to ABW, A times
Yes.
B times W. So here C, so this is for the students. So here the C is a matrix and A and B are also matrices. So they are 2 cross 2 matrices, and the W is a vector of 2 cross 1, of size 2 cross 1. Now what you are saying is that you are equating two systems, like CW is equal to ABW, and you are saying that from this C equal to AB. Now how many ways are there to show that C is equal to AB? So what are the, like, from this equation, although it looks like this is obvious, like when CW is equal to ABW, and without realizing you may conclude that C is equal to AB. But can you give like a precise argument that this is how, I mean, this is the way, because you are equating two matrices. You are saying that C, the matrix C is equal to the matrix A times B. So when do you say that two matrices are same? The matrices are same when they are same entry wise.
Yes.
Right? So how do you conclude from here? Can you like give some precise argument that this is the way that you can show?
So
From
we
the
can write
equation
here.
CW is equal to ABW. This is true for all W. From here, can you, yeah.
So we can write here AB minus C into W equal to 0. And since this
Right.
follows for all W, so AB minus C has to be 0. This implies AB equal to 0.
Why?
So why for what?
Why? So this is true for all W.
Arbitrary.
Yes, sir.
So
why?
what? So what? So what?
So one of those are 0. So C minus AB is 0. We can take it.
C minus, so see, you are saying AX equal to 0. If X is 0, implies A is 0. But what is the argument? So this you are using some result. But I'm asking, what is the reason behind that? You are saying C minus AB W equal to 0 for all W, and therefore C equal to AB. But why? This is some result you are using. Some statement you are
W
using.
is a vector.
Sir,
W is a
if
vector
W is
from
not
R
equal to
square.
0,
Sir,
If W is
a
not
vector
equal to
from
0, so
then AB minus C has to be 0. Sir,
why?
सर बिकॉज सर यूनिक सॉल्यूशन सर एग्जिस्ट नहीं कर रहा, तो सर इसका इनवर्स एग्जिस्ट नहीं करेगा, इनवर्स एग्जिस्ट नहीं करेगा, तो सर डिटरमिनेंट 0 होगा, डिटरमिनेंट 0 होगा.
So no, so you're using something which is not necessarily true here. A homogeneous system can have a non-trivial solution, no?
Yes.
Sir,
So this
equal
is
to
some
0 है.
Yes.
Equal to 0 है. So equal
So?
to मतलब कि AX equals to 0 है, तो X एक मैट्रिक्स है एंड सामने 0 मतलब वो 0 मैट्रिक्स है. अब X अगर आर्बिटरी वेक्टर है और A कोई वेक्टर है, तो A को नॉन जीरो वेक्टर मतलब नॉन जीरो मैट्रिक्स ही होना पड़ेगा, क्योंकि अगर मतलब किसी आर्बिटरी मतलब कि वेक्टर से मल्टीप्लाई हो रहा है, तो मतलब वो क्या कहते हैं, टू वेक्टर्स का प्रोडक्ट जीरो वेक्टर तभी होता है जब दोनों में से कोई एक वेक्टर 0 हो.
See, you are using some argument, this is something like, this is why I came in between in your discussion. This is some kind of obvious, which we feel like this is obvious, right? But you are not able to
Not necessary,
answer
sir.
it properly.
Sir, can I speak?
Yes.
Sir, we can take W as 10 and again
Yes.
W as 01.
Yes, so this is the precise way to do it. See, this statement is true for all W. So whatever W you take, this C minus AB times W equal to 0. This is true for all W. And using that, you have to show that C is equal to A times B. These two matrices. And when you can say these two matrices are same, when they are entry-wise same. Now this is true for all W. So you take particular choice of W and try to conclude that C entry-wise C and A times B are same. So whenever you have this kind of argument, like with this kind of a statement in the following, like in any mathematics course, so if you have this kind of a statement which is true for all vectors, for all matrices, for all functions, and then using that, if you want to conclude something, then you try to take some particular functions or some particular vectors, some particular matrices, depending on what you are dealing with. In this case, this is true for all W. So you make some particular choice of W, and using that, you show that C is equal to AB. Now this is the correct statement, that if you take W as 1 0, or let's say 0 1, or take 1 1, this will give you some kind of equations, and after solving this equation, you can show that entry wise C and this matrix A times B, they are same. So this is how you should try to think why this is true from this step. So why you are concluding C is equal to AB from the previous, because of this. Although it was very obvious, I mean, we feel, I mean, it's not only you, most of us feel like it is obvious, it will follow immediately. But then see, most of you have not answered it. The precise answer, you did not do that. So think in this way, and the tutorials, these discussion sessions are for this purpose only. You give your argument, and then we try to see whether you are going in the right direction or not. Okay, yeah, Mohit, please continue. Sorry for the interruption.
No, sir. Thank you, sir.
Thank you, sir.
So as you see that, so where are the gaps in the arguments that we just skipping the thing, okay? So you just think it off about this question, and we will move further in the next for the next problem. Yeah. So what is your try for the next problem? So first, can anyone tell me what do you understand by this lower triangular matrix?
The entries below the diagonal is 0. So upper triangular matrix, and the entries above the is lower triangular matrix.
So for the lower triangular matrix, the entries below the main diagonal are 0. Okay, we don't care about the entries on the diagonal and above the diagonal, but the entries, yes. So like null matrix, you can take a square null matrix, that is also a lower triangular matrix as well as upper triangular matrix. Okay. Similarly, for the upper triangular matrices, the entries above the main diagonal, that must be 0. We don't care about the other entries. Okay. Now how will you answer this, the part A? I mean, what is your try? What is your argument?
सर नल मैट्रिक्स को भी हम ट्रायंगुलर मैट्रिक्स बोल सकते हैं, अपर ट्रायंगुलर मैट्रिक्स, लोअर ट्रायंगुलर मैट्रिक्स.
Yeah, what were you asking?
सर नल मैट्रिक्स होती है, उस नल मैट्रिक्स को भी हम अपर ट्रायंगुलर, लोअर ट्रायंगुलर बता सकते हैं, किसके अंदर सभी वैल्यूज, सभी एंट्री 0 होती है ना.
हाँ, yes, because the definition is the entries below the diagonal, main diagonal should be 0. We don't care about the entries on diagonal and above the diagonal for lower triangular matrices.
सर फर्स्ट पार्ट के लिए सर इसमें क्या है, जो भी अपर लोअर ट्रायंगुलर मैट्रिक्स है L1 और L2, तो उसमें हमारा जो भी AI J होगा सच दैट j की वैल्यू i से बड़ी है वो हमेशा 0 होना चाहिए।
यस
हाँ, तो अगर हम ऐड करेंगे दो मैट्रिक्स को तो हमेशा वो एंट्री वाइज ऐड होते हैं, तो वो 0 के 0 ही रहेंगे, तो हमेशा ये 0 मतलब लोअर ट्रायंगुलर मैट्रिक्स से बनेगा।
yes, the argument is correct, but you said like for I is less than equal to j or I is greater than equal to j. I mean whatever
I less than equals to j,
and those entries should be 0.
0.
Yes, so that yeah, so that is fine with this a. So is the point is clear to everyone, this whatever she's trying to say?
Yes, sir, clear.
Yes, sir.
Yes, sir.
Yes.
Because if we see how we add the two matrices, these are entry wise and 0 plus 0 will remain 0. So if L1 and L2 are two lower triangular matrices, again the sum is again lower triangular. Same is the case with U1 plus U2, but not with the B. So what is your guess for B? Is it
Neither.
Not
Lower
always.
Neither triangular matrix, not upper triangular matrix, not.
yeah. So when you are saying like the negation of something, then you have to supply. How will you claim your answer? You have to give some
By giving example.
some example.
By counter.
Yeah.
सर अगर इसमें कोई नल मैट्रिक्स को ऐड करा है इसमें, जैसे अपर ट्रायंगुलर मैट्रिक्स को लोअर ट्रायंगुलर मैट्रिक्स में कर दिया ऐड नल मैट्रिक्स को, तब भी फिर हमें लोअर ट्रायंगुलर मैट्रिक्स मिलनी चाहिए अगर हम नल मैट्रिक्स को बोलते हैं लोअर ट्रायंगुलर मैट्रिक्स, अपर ट्रायंगुलर मैट्रिक्स।
But the thing is here that for the point B, we are saying that are not lower triangular. Okay, so we are giving some particular example to say that this U1 plus U1 plus L2 is not lower triangular matrix. Okay, so because for like if you are taking L2 to be, let's say, null matrix, so that is one example where it is upper triangular, that is fine, but it should be true for every matrix. Okay, it should be true for every matrix. Then only you can say that okay, U1 plus L2 is let's say upper triangular or lower triangular likewise. So you, as some of you are pointing out that this U1 plus L2 is neither lower triangular matrix and nor upper triangular matrix. So they are having some examples with them which is not satisfying these U1 plus L2 is lower triangular or upper triangular. Okay, so you have to, if you have any one example which will not satisfy, then you can say it is not. Okay, for by giving some example and you are proving that okay, this is a lower triangular matrix, that method is wrong. You have to take care of all the entries for the matrix in general.
Okay.
Okay. Yeah, for C part.
C part is upper triangular matrix.
That is fine. That is fine. But how will you? What is your argument?
Multiplication.
By taking general matrix.
Yeah.
General matrix.
So have you tried with this way? You have to take U1 and U1. I mean U1. Let's say n by n upper triangular matrix. That is an upper triangular matrix, and then you just multiply and see what is the product will come.
Yes, sir.
Yes, sir.
Yes.
So all of you have tried, right? Like this way, right?
Yes.
Yes, sir.
Yes. Then it is fine. This is the correct way to do. Okay. For D part, what is your guess?
Can't say.
I take counter.
Neither.
Sir,
Can't say what.
Neither.
So you are having some example, right? For D.
Yes.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
So
सर नाइदर नोर की जगह अगर नीड नॉट बी कहें तो
neither nor की जगह need not be अगर बोलोगे, need not be, what do you mean by need not be?
जरूरी नहीं है
That
कि
is okay, so let me ask you first a question. Suppose, so I have told you the definition. When do we say that a matrix is a lower triangular matrix? Okay. Now I am asking you, when do we say a matrix is not a lower triangular matrix? Please mute yourself after asking question. And unmute only if you want to ask. So okay, so I'm asking you, when do we say that if a matrix is not lower triangular matrix?
सर अगर उसके लोअर एंट्री में कोई एक भी नंबर नॉन जीरो हो जाए,
Non-zero हो जाए, correct. So because that is violating the definition. Okay.
Yes, clear.
So now the thing is clear. You are saying the need not be case.
Yes, sir.
Okay. So if you are having some example of like L1 and U1, so that this L1 the product will product is upper triangular or not, or lower triangular or not, then you are done. So can anyone tell me if you have tried? What is your example you just have chosen for D part?
Sir,
Sir, if
take
we
L1
multiply
1203.
Sorry, one by one. 1203.
And U1 is 1023.
U1 is 1023. So yes. So now what is the result? Everybody can see. If you try with this example, now what is the result of this L1 U1? Is it a lower triangular matrix?
Sir, all four entries are non-zero but not calculating. Just
but not. Sorry, your voice is breaking. Hello.
Sir, your screen is paused at question number 4.
मैंने एग्जांपल ले लिया है बट मैंने अभी जस्ट किया ना तो फिर कैलकुलेट नहीं किया, बस इतना पता कर लिया कि चारों एंट्रीज नॉन जीरो आएंगी.
Yes. Okay, fine. So it is not upper triangular and also nor lower triangular. Actually, my screen is not paused. I have just not shown you the answer. Now you can look to the answer.
Yes, sir.
Okay. So that's how you can. So for lower triangular matrix, this is the.
सर
Sorry.
सर डायगोनल मैट्रिक्स भी तो अपर ट्रायंगुलर मैट्रिक्स लोअर ट्रायंगुलर मैट्रिक्स हो सकती है ना?
हाँ बिल्कुल.
अगर इसमें मल्टीप्लाई करते हैं तो फिर ये मिल जाएगा, कोई ऐसा एग्जांपल मिल जाए इसमें नाइट एंड नोर के लिए कह रहे हैं ना.
But the thing is that okay. So yeah. So okay. So if you don't have to, making some confusion, you can say it is need not be, because if you are interpreting nor not low upper triangular, if you are interpreting this terminology nor upper triangular or nor neither lower triangular by saying not upper triangular as it is the case, so you can say it is need not be, that you can write it this case, because by saying with one example, if you take L1 to be diagonal, U1 is also a diagonal matrix, and then obviously this product is also a diagonal matrix and it is also lower triangular and upper triangular. But
sir, sir, if we get a single example which is contrary, then directly we can say na it is not a lower and upper.
Yes, you can say. Yes, you can say. But the confusion. What is actually they are interpreting this not, because it is for every metric. So they are interpreting not. The not upper triangular thing
May
is
or
by.
may not be.
So you can write. So be clear with your logics. If you are like having some problem with this, then you can write may or may not be, because you have to be clear with yourself. The thing is here that this L1 U1 is also a diagonal matrix, that is also possible, the lower triangular, but here you have to supply an because you have to just keep this lower triangular and upper triangular, these two things, just forget about other things, not definition. Lower triangular may you just have to keep in mind that there are some example where this L1 U1 is not lower triangular and as well as not upper triangular. So you just give some example and just write may not be possible. And for for E,
Same counter.
Same case.
सर इसके लिए भी ऐसे ही सेम सोचा था.
Yeah, so you can.
We got the counter, sir.
Yes. So you can see in solution C, you can write in this way. You just need not be writing all the stuff like U11 and up to U1n, and so you can try this way, so you can save some time in your exams if you write with this way. Okay, and so here we have.
सर ये स्लाइड्स प्रोवाइड हो जाएंगी क्या हमें?
That we will see because already the lectures are recorded, so we will see. Also, these are, yes, we can provide. Yes. Are you saying something?
Yes, sir. Lectures are already provided, but PPT मिल जाता है तो ज़्यादा आसान होता है.
So okay, we will discuss with the course coordinator and other TAs, and then we will although it is not very harsh thing. I mean, we will share. It is not the matter. So right now the thing is that you just understand the concept and what is the logic behind all the questions, and what is how to present your answer. That is the main thing. So are we done with this question number 5? Okay, so
Yes, sir.
yeah.
Yes, sir.
So for so you want me to continue with question 6, or can we continue in the next class? Because somebody is asking about the question 6.
Sir, in next class.
Sir, 5 minutes left.
Okay. So
please give the idea of question
yes,
number
yeah.
6. I wanna try by myself.
Yeah. So
Just give me an
your doubt
idea.
is question 6 and 17, right?
Yes,
Yes, sir.
मैं
Just
rotation
give
ही पता
me
नहीं.
idea.
Okay, so
Yes, sir.
we will discuss it also in the next class too. So those who want, those who have some next class or something, they can leave. And if you are interested to be here in the discussion for further for the next few minutes, then you can listen us. And you may leave if you have any other class or also. We will discuss it again. That is. Okay. So now for question 6, what does it say? What do you understand? What is the question 6? And
इसमें
what
ये
is your
बताना है
doubt
कि
precisely?
ये 2 वेक्टर्स हैं.